Hello everyone. This article describes the CAN protocol in general and also describes the native Adaptronic CAN system. First of all, CAN is short for Control Area Network. It's a multi-drop broadcast protocol. The physical connection is via a twisted pair with a high signal and a low signal. When the bus is in the recessive state, both the high and low signals are at the same voltage. When the bus is in the dominant state, the high line goes to a higher voltage and the low line goes to a lower voltage, with the average voltage being the same. This provides excellent noise immunity and is a similar principle to many other twisted pair protocols such as RS485, RS422, Ethernet, and even good old analog phone lines. And none of these are shielded usually, and they operate over very large distances. Multiple devices can be connected on the bus in parallel, and there's no bus master, so any device can broadcast a message. Because it's a twisted pair, at each end of the bus it should be terminated with a 120 ohm resistor. Now, because of the way the CAN works, every device on the bus must be set to the same bit rate. If you have two devices on the same bus with different bit rates, then as soon as one starts to broadcast a message, the other one, which is set to a different bit rate, will detect as being corrupt and will actually overwrite the message to avoid any other ones being confused by a corrupt message. So it's very important to make sure that all the devices on the same bus are set with the same bit rate. Each CAN packet contains an identifier, which is either 11 or 23 bits in length, and then it has up to 8 data bytes. The identifier is what allows other devices on the bus to know which device sent the message and what it means. All modular ECUs have at least one CAN bus, with many such as the M6000 having a second CAN bus connection as well. All the settings and functions are the same for both buses, so we'll only discuss one of them. In the Adaptronic software there are many CAN settings, so I won't discuss them all in this article, but we'll discuss the basics. The first is a bit rate, which we mentioned earlier. The default is 1 megabit per second, which is also the highest rate, but lower rates can also be selected so long as they divide into 1 megabit per second. You can also select an option here to disable the CAN function completely, and that allows the bus to be free, so you're not going to interfere with anything else on the bus. The second is the inbuilt termination resistor. So the ECU has an inbuilt 120 ohm resistor to terminate the CAN bus, and that can either be enabled or disabled using the software setting. So in accordance with what I described before about the CAN bus needing to be terminated at each end of the bus, this means that if the ECU is connected to the end of the bus, then you should enable the termination resistor, and if it's in the middle of the bus, then you'll need to disable it, and it should be terminated at each end still. There are settings for receiving wideband lambda over CAN, and also the non-native CAN output modes such as the emulation of the Haltech or the RacePack systems, but I won't go into those in this article. But as well as those, each CAN bus can also send data out in the Adaptronic native format. This gives you a direct window into the live variables inside the ECU, in the same way that you can see almost any variable from within the Eugene software on the gauges or the monitor panels. All these live variables are 16 bits, which means that each variable takes up 2 bytes. Therefore, 4 of these fit into a CAN packet. The software supports up to 1024 live variables, and therefore there are up to 256 different CAN packets that can be sent. Each different CAN packet has a unique ID. The default base address is 300 hex, so therefore these CAN packets can have IDs in the range of 300 hex to 3FF. You can select which channels are transmitted so you can avoid a whole lot of data that you don't need and maximize the data rate. The settings available are as follows: bitrate, as we described above, termination, which is the default is on, enabling of the Adaptronic CAN output, the base address, where the default is 300 hex, and also the enabling of any additional CAN channels. There are some channels which are always transmitted, which are the basics like engine speed, battery voltage, manifold pressure, throttle position, and so on. Now, in addition to this, you can select any other variables that you want to see as well, and you can select that in the software. Once you've done that, you can actually press a button in the software, and it will generate a document showing all the variables which have been transmitted, all their CAN addresses, and their locations within each CAN packet. The document for the standard configuration is attached to the article version of this video, so you can configure any dash which has got a variable CAN system to use it. Thank you very much.